Alright, so today, since I'm obviously not there, I still want to go through and continue some of our lessons. So, with these, if you have a pair of earbuds that plug into your laptop, that's going to work best, or maybe even sharing your earbud if you're comfortable doing that. Or as you're listening to it on the laptop without anything, try not to have it too loud to bug those around you. But I'm changing the order up a little bit because this is a topic we were actually going to do later in the week, but with me not being there, I figured this is an easy one for you guys to do without me. So what we're going to work on is called the midsegment theorem. THM is the short for theorem. You'll see me write that, quite often. Alright, so midsegment theorem basically means that, let's say you're starting off with a triangle like the one I have on the screen. A midsegment is going to be a segment. Oops, sorry, it would kind of help if I'm not on the eraser. It's going to go through and cut your triangle. Basically, it's going to have a mid-segment. And the way that they make that a mid-segment is this segment right here is going to have one slash, and this one's going to have one slash. It means those are two identical links. And the same kind of idea at the other side. They don't have to be the same, so I could put this one with 2 marks, but this one down here is also going to have 2 marks. So what that means is in this triangle, that segment right there is a mid-segment. It's in the middle, kind of like thinking back to your midpoint. It's in the middle of that triangle. Now, it has a lot more properties than just being in the middle as well. When you have a mid-segment, that line is parallel to that line. Okay, that's the definition of a mid-segment. And one of the other properties about these, I'm going to change colors here a minute. If it'll let me do it. There it goes. Alright. Thinking back to things that we started out with in this unit. So you don't have to draw this if you don't want to, but we went through and we did parallel lines cut by transversals. We had certain angles that were congruent. Okay, and you have the same thing with these, because right there, if you look at your midsegment, you have parallel lines. So this one, I'm going to try shading in red, that angle right there is congruent to that angle there. Okay, see, we have our parallel lines cut by our transversal, which is that right-hand side. So those right there are corresponding angles, so those are congruent. And this segment, or that angle, I'm sorry, is going to be congruent to that angle there. Again, corresponding angles. So this kind of wraps into what we were looking at the other day. Now, that's not the only property too. So we're looking at a bunch of stuff when you're talking about a midsegment. That segment, again, is exactly in the middle. It's a midpoint on both sides. Those two segments are parallel. And I'm going to go ahead and name the vertices for this one. A, B, C, D, oops. D and E. Now, those properties are all good and all well and good, and you're going to have problems to deal with those different properties. But the big theorem when you're talking about a midsegment that you're going to see most often is talking about how this side, or this segment B to E, relates to C to D. And you can write this property out 2 ways. If you take half of the length of the segment C to D, it's going to equal the length of B to E. So this is one way that you could write that. So if I were to take this bigger segment and divide it by 2, or half it, it's going to be the same length in this case as B to E. And that's usually the version that you're going to see on the textbooks. But most of you guys really don't like working with fractions as much as possible. So there's another way that you can write this formula that means exactly the same thing, and this is the one I generally use in class. So we already know that B to E is half the size of C to D. Well, if we were to multiply 2 times our B to E segment, that's going to equal our C to D. These two properties mean exactly the same thing. You're basically saying that B to E is half the size, or if you were to multiply that B to E by 2, you'll get the length of C to D. Now, even though there's 2 of them, this is the one I will generally use. Hence, it has no fractions. So it's a little easier to work with when you're multiplying things. So a lot of our problems we're going to look at are going to deal with that. But keep in mind, midsegment isn't just that property. It's all these other parts we're talking about too. So if you need anything from the screen, pause the video, because I'm going to switch screens. Okay, so we're going to do some very, very easy examples first. There's a couple of these in your homework, and it doesn't have any marks on it, or at least naming your vertices, but if you're given this middle segment, as automatically I can tell this is a midsegment just by looking at the marks. I should be able to find this segment really easily. Well, we just kind of talked about it. If we do 2 times the smaller one, that's going to equal our bigger one. So that means that this has to be 8. Or vice versa. If I happen to know this one, okay, this is my longer segment, my smaller segment is half of that size. Well, if my big segment is 10, then I automatically know that the smaller segment on the inside is going to have to be 5. Okay? So you have a couple of those in your homework where you just have to, it's giving you just a regular number, you just have to find, I may give you the longer segment or I may give you the smaller segment. So again, if you need anything from this, pause the video. Okay, so now we're going to look at some more algebra versions of these. So as soon as you start seeing these markings, these midpoint markings, automatically it's a midsegment theorem. So again, I will stick to the second formula. If you multiply this smaller segment by 2, so 2 times x plus 2, it's going to equal this larger segment right here, which is going to equal 3x minus 7. And from there, it's just an algebra problem. I'm going to have to go through and do my distributive property. Back from math 1, so 2 times x, and I have to do 2 times 2. So 2 times x will give us a 2x. 2 times 2 will give us 4, equals 3x minus 7. Well, I have x's on both sides, so I'm going to have to move one of them. I will generally move the smallest one, so I'm going to minus 2x to both sides. So that gives me 4 is equal to x minus 7. So all I have to do is just add 7 to both sides. So 7, 8, 9, 10, 11. So x is equal to 11. Okay. So a lot of these types of problems, this is the thing that you're going to be going through and finding. Now, some of your questions are just going to ask you for x, whereas other ones might ask you to find certain lengths. So this one, I'm going to change it up just a little bit. A, B, C, D, and E. We're going to find B to E, let's say. Well, in order to find B to E, or the length of that B to E, I'm going to have to go through and find my x value first. So I'm going to have to do the same thing we did just a little while ago. I'm going to have to multiply this middle segment by 2, the smaller segment. And we know that that's going to equal 5x minus 3. Alright, so again, we're going to have to go through and do our distributive property. So 2 times 2x, and then we're going to have to do 2 times 1. So 2 times 2x will give me a 4x. 2 times 1 will give me 2, is equal to 5x minus 3. Alright, well now, again I got x's on both sides, so I'm going to move the smaller one. So minus 4x to both sides. So I get 2 is equal to x minus 3. Again, I add 1 to both sides. Oh, sorry. I don't know what in the world I'm doing. Adding 3 to both sides. It's Monday night. So adding 3 to both sides. So in this case, I get that x is equal to 5. Well, that's all well and good. But the question wasn't asking us to find x. It's saying find b to e. So be careful with these problems. Make sure that it's finding what you're looking for. So in this one, b to e, you know that b to e is 2x plus 1, according to my picture. Well, I just found out that x is equal to 5, so if I just plug in 5 in for x, I can solve. 2 times 5 is 10, plus 1 gives me 11. So b to e in this case is 11. So again, just make sure you're careful with those. Most of your problems are going to be this way, more of an algebra-based mid-segment there. So again, if you need anything from the screen, go ahead and pause it. I'm going to change screens. Okay, so you may see some like this as well. Sorry, I was erasing earlier. It says, if B to E is the mid-segment of triangle ACD, what is X? Well, as soon as they say that this is a mid-segment, automatically it means I'm going to have these types of marks where, you know, A to E is congruent to E to D and A to B is congruent to B to C. Well, since it's a midsegment, I know that that segment has to be congruent to that segment. Well, if those two are congruent, then I can just set them equal to each other. So 3x minus 1 has to equal 5x minus 7. Again, x is on both sides. I can go through minus 3x to both sides. So I get negative 1 is equal to 2x minus 7. Add 7 to both sides. I get 6 is equal to 2x. Divide by 2. And I get that x is equal to 3. Okay? So just be aware, the x is not always going to be with the midsegment, the smaller segment, or the larger segment. It could also be with the sides. But as long as you know it's a midsegment, those sides are going to be the same. Alright, so again, if you need anything from the screen, go ahead and pause it. I do want to look at one other thing. Okay, so again, kind of talking about your angles. Let's say, I'm going to change it up a little bit. Oops. Say D, E, F, G, H. Alright, and if I have these sort of marks, and let's say this one is 75 degrees. Now these could be more algebra, but especially since I'm hand drawing these, I'm not going to want to go kind of crazy with them. Well, I could find some of these other angles, because again, if that's a midsegment, which it is, it doesn't even have to show the parallel lines. As soon as you see those midsegment marks, automatically these are parallel. So there's my parallel lines, cut by my transversal. So that segment has to be congruent to that segment. Those are corresponding angles. So if this one's 75, this one right here is also 75. Okay? And you may have more of an algebra base to be able to find that too, where it's, one of them's 5x plus 1 and one's x minus 2 or something like that. But just remember, you have all these different properties when you're dealing with a midsegment.